Hi there, my name is Miss Townsend and I like math. Welcome to Math with Townsend. This video is for calculus students. We're working on optimization problems, specifically related to functions that are exponential or logarithmic in nature. In particular, it's section 8.4 in your textbook. I'm going to be looking at question number 4 on page 322. Here's the question. It says the net monthly profit from the sale of a certain product is given in dollars by this formula. So this is a formula for profit in dollars where X is the number of items sold. And it says find the number of items that can yield the maximum profit. So as soon as we know that we're dealing with a question about maximizing something, we know that we are looking at an optimization question. So we need to maximize the profit. And we know that at full capacity, they can produce 2,000 items per month. And that tells me that I'm limited to looking for values between 0, meaning don't make any products. That would be an awfully strange way to maximize profit, and 2,000. So let's go ahead and do the first step is we need to take the derivative of the function in order to determine critical values. So the function, so p at x is 10 to the 6 times 1 plus x minus 1 e to the negative 0.001 to the x. So personally, sorry, my kitten just wanted attention. I'm going to actually, even though I know it's ridiculous to do this, I'm going to multiply that 10 to the 6 in just personal preference here. Because now when I take the derivative, I'm not at all worried about messing up something. Derivative of that is 0, so ignore it. So now I'm going to take the derivative of this. So I'm going to consider this to be first function and consider this to be second function, and I'm going to apply the product rule. So the derivative of the first is 10 to the 6 times 1. And then, so derivative of the first times the second, that's what that is. Plus derivative of the second. So derivative of the second, it's base e. So exactly what I see times the derivative of that exponent. So that's the derivative of the second, and then I have to, of course, say times the first. So there is the derivative, and now I have to do math to make it look proper. So obviously I'm going to factor out 10 to the 6 and e to the negative 0.001x, and that leaves me with 1 plus, and I'm just going to leave this stuff for the moment in their brackets. So again, it's always a good idea to double check that if you were to multiply, you'd be correct. So if I take this and multiply by 1, I have the first. And if I take this and multiply it out here, I have this. Yes, 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 yes. Okay. So I have 10 to the 6 times e to the negative 0.001x. And then just cleaning up what's in this bracket here. Oh, this is 1 minus 0.001x plus 0.001. So obviously I could have done this all in one step. I don't think you're here to watch me do addition. Oh, maybe you are. You're looking at the wrong place. Okay, so there's the derivative, as beautiful as I can make it. And now the next part of maximization or optimization is to make it equal to 0 and solve. So I have this expression. Oops, this expression, I'm going to call that the first. So any x values that make this a true statement would be considered critical points. And then obviously I have this expression. Any x values that make that into 0 are critical values. Obviously there's no solution here. No solution because I can't put an exponent up here that would make this equal 0. And over here, if I solve for x, I get that x is equal to 1,001. So there's one critical value, and if we go back to the question and look at the intervals, 1,001 is in the interval, so I test 0, 1,001, and 2,000 in the function. So just subbing those values into the function. So p at 0 gives me 0 profit. Makes sense. Don't make anything, don't make a profit. If I sub 1,001, I get a profit of 368 million. A whole big nice profit. Make sure you're paying your employees properly and you're following environmental regulations. No one needs a profit of $368 million. Sheesh. Hopefully you're doing good with that. Okay, so those are the profit values. So obviously if we want to maximize profit, we do it by producing 1,001 items. Now part B of this question says, hey, what if we go back to the actual question here, part B says, what if at most only 500 items can be produced? Well, what that means is that the interval that we would need to test would go from 0 to 500. And obviously that means we don't even test our critical value. So we're only going to test 0 and 500. So we already know that the profit at 0 items produced is 0. So presumably the max profit would be to produce 500. And so that is definitely bigger than 0. So that would be the maximum profit would be to produce 500 items if that's the most that the industry can produce, or something, blah blah, economic word. Anyway, I hope that was helpful. Obviously the focus is not the profit, it's the taking the derivative and finding critical values and testing. Hope that was helpful. Bye.